Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. We've been waiting for you and we are glad that you are finally here. In this video, we're looking at WAEC past questions on area and perimeter from 2014 to 2023. This is like the capstone of all of those videos that we've been doing. We've been talking about areas of different shapes, perimeters of different shapes in the previous videos to this. And if you have not seen any of them, I advise that you go to the playlists and start from the beginning, so that you don't miss out on anything. It's very important that you don't miss out on anything. If you watch this WAEC past question video, yes, you might get the questions, but there's some tricks that you would not be able to, or you may not be able to overcome. So I encourage you once again to watch this from the beginning. And without further ado, let's get started. The first question says that the angle of a sector of a circle of radius 3.4 centimeter is 115 degrees. Find the area of the sector. Take pi to be 22/7. This is from June 2023. As always, I would admonish you that you pause the video and you try it out yourself before you play and watch how we solve it. I would not be saying that at the end of reading out of every question, so you need to know that. So let's solve this together. So what are we given? Let's start from there. We are told that the radius is 3.4 centimeter and the theta is 115 degrees. We are told to take pi to be 22/7. So for the area of a sector, let's say AS, what formula is that? Great, that's theta over 360 times pi r squared. So let's just substitute. Our theta is 115 all over 360 times 22/7 times 3.4 all squared. So I'll just take out my calculator and just punch it. 115 divided by 360 times 22/7, then times 3.4 all squared. So that gave me 11.661 centimeter squared. That's two decimal places. Let's see if you are correct. So that would be option A. Great. Question 2 says that the diagonals of a rhombus are 16 centimeter and 12 centimeter. We should find the length of a side. This is from June 2023. So just like we said before in our previous video, we have a rhombus. Let me say these are rhombus, and it has diagonals. So we said the diagonals are something like this. Let me just, okay, and the other diagonal would be something like this. Great. So this diagonal is 16, this diagonal is 12. We said something in the video where we're talking about rhombus, that the diagonals, they are not necessarily equal. In fact, they're not even equal, but they divide themselves into two equal halves. So if this guy is one of 16, this guy will be 8 centimeter, this guy will be 8 centimeter, and this guy is one of 12, this guy will be 6 centimeter, and this guy will be 6 centimeter. So if I take one side, so let me just take one side of it, something like this. This side here is 6 centimeter, this side here is 8 centimeter. So I thought to find the length of a side, which is this guy. Let me just call it x. And of course, we said they bisect each other at right angles. So all these guys here are 90 degrees, 90 degrees, 90 degrees, 90 degrees. So there's a 90 degree here. So we could say from Pythagoras, what does it say? It says that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So that would be x squared is equal to 6 squared plus 8 squared. And that would be x squared is equal to 36 plus 64, and that would be x squared is equal to 100. And if I take the square roots of both sides, that would be x will be equal to square root of 100, and that would be 10 centimeter. So the length of a side is 10 centimeter. Let's see if we're correct. That would be option B. Great. Question 3 says that the length of a diagonal of a square is 12 centimeter. Calculate the area of the square. This take from June 2023. Remember, they did not say the length of a side of a square. They said the length of the diagonal. So you have to be very careful about that. Let's solve it together. So if these are a square and we want to get the diagonals, this will be something like this. First diagonal, and the second diagonal will be something like this. Great. For a square, all the sides are equal. So if this side is x, this side will also be x, this side will also be x, this side will also be x, right? We know that already. Then this guy here is 12 centimeter. This other guy here too is 12 centimeter. So if I just take one part of it, let me just take this side here. So that will be something like this. We have x, and we have 12. So, and of course this is a right angle because it's a square. All these guys are right angle, right angle, right angle, right angle. Right. So we could say from Pythagoras, let me say something here. For a square, it also bisects equally. So this guy will be 6, this guy will be 6, this guy will be 6, this guy will be 6. But for a rectangle, it does not bisect equally. So you need to know that. And we discussed that in those previous videos to this. So we said from Pythagoras, hypotenuse squared is equal to the opposite squared plus adjacent squared. So that will be 12 squared is equal to x squared plus x squared. So that will be 144 is equal to 2x squared. So if 144 is equal to 2x squared, I can divide both sides by 2. That will give me x squared to be equal to 72. So x will be equal to square root of 72 if I take the square root. So square root of 72, I want to do it in terms of surd. That will be 36 times 2, right? Because 36 times 2 is also 72. So I can find the square root of 36 easily. And that will be 6 root 2. So that is the length of one side. But what they tell us to find? They tell us to find the area of a square. So we know that the area of a square is the length of a side and you square it, right? So a side times a side, which is L squared basically. So we could say that is 6 root 2 all squared. 6 root 2 all squared, that will give you 36 times 2, and that will give you 72 centimeter square. So the area of this square is basically 72 centimeter square. Let's see if we're correct. That will be option C. Great. Question 4 says that an equilateral triangle has a side 2 centimeter, which calculate the height of the triangle. This is from June 2023 too. So for an equilateral triangle, we know that all sides are going to be equal. So if this is our triangle, if this guy is 2 centimeter, this guy will be 2 centimeter, and this guy will be 2 centimeter. And all the angles here are 60 degrees, right? So this guy is 60 degrees, this guy is 60 degrees, and this guy is 60 degrees. So if I divide this, right, when I divide, like if I draw a perpendicular line at the middle, it also bisects the side. So this side will be 1 centimeter, this guy will be 1 centimeter. So if I blow that up, this will be something like this. The angle here is 60 degrees, this is 90 degrees, this 2 centimeter, this 1 centimeter. And this place is basically the height, which is the h that we're trying to find. So we know that from Pythagoras, hypotenuse squared is equal to the opposite squared plus the adjacent squared. The hypotenuse is 2, so that will be 2 squared. The opposite is h, that will be h squared. The adjacent is 1, that will be 1 squared. So that will be 4 is equal to h squared plus 1, and that will be h squared is equal to 4 minus 1. So our h squared is equal to 3. And if I take the square roots of both sides, that will be h will be equal to square root of 3 centimeter. So these are our value for the height. Once you know a equilateral triangle has equal sides and 6 degrees, you can take a perpendicular, right, and get the height. So let's see if answer is correct. That will be option D. Great. Question 5 says that in the diagram PQR, where's PQR? This is our P, these are Q, these are R. So PQR is an equilateral triangle of side 18 centimeter. It says M is the midpoint of QR, and an arc of a circle with center P touches QR. So an arc of a circle with center P, so this is the center of the circle, touches QR at M. This is the M here. So now says that and meets PQ at A. So it meets PQ at A. That means that this place there is not the entire length, it's just a portion. And PR at B. Yeah. Calculate correct to 2 decimal places the area of the shaded region. Take pi to be 22/7. This is from June 2023. I'm assuming that you've also paused the video, or you pause the video now and you try it out yourself. Let's solve it together. So if it's an equilateral triangle, this side is 18 centimeter, this side is 18 centimeter, and this side is 18 centimeter. And that means that the angle here is 60 degrees, just as for every other angle. So look at this. The area of the shaded region this is a triangle, so I could just say the area of the shaded region will just be the area of the triangle, right? And if I remove this area of the sector from it, you see that there's a sector here. If I remove the area of sector from the area of the triangle, I'll be able to find the area of the remaining portion, which is the shaded region, right? Great. So for the area of the triangle, I mean, we could use half AB sine theta. We've talked about this, but the theta must be the angle between two sides. So if I say this theta, the two sides that are about theta, 18 and 18, so that will be half times 18 times 18 times sine 60 degrees, right? So that will be 9 times 18 times sine 60 degrees. That would be 81 root 3. Or you could use the decimal value, it's still the same thing. Now we found the area of the triangle. What of the area of the sector? The area of the sector, we know that this angle between them is 60 degrees, but the r, the radius, is not this entire length. So we need to find that portion. But here is something interesting. From here to here will be the radius, Abi, and that will be the same distance as here to here, and the same distance as here to here. So if I take out, look at this is the big triangle, right? This guy here, this is the r, this is the full length here of this guy, the full length. This is 18 centimeter, and this guy here. Remember, this guy is bisecting. The m is at the midpoint of QR, just like they said m is at the midpoint of QR. So this place here is 9 centimeter, and this place here is 9 centimeter. So this is 9 centimeter, and this is also 90 degrees. So we can find what this r is. If I find what this r is, it will be the same as this guy, it will be the same as this guy. So we will know the radius of the circle from there. So from Pythagoras again, the hypotenuse squared is equal to the opposite squared plus the adjacent squared, and that will be 18 squared is equal to r squared plus 9 squared. So our r squared will just be 18 squared minus 9 squared. 18 squared is what? 324. 9 squared is 81. So 324 minus 81, that will give me 243. So our r squared is equal to, so if I take the square root of both sides, our r would be 9 root 3. And I'm sure by now you should know how you can be able to get all these 9 root 3 and all of that. So 9 root 3 centimeters. So that's our r. So based on that, we can find the area of our sector, which would be theta over 360 times pi r squared. Let me say capital theta, because I use capital r here. So our theta is 60 over 360 times 22 over 7 times 9 root 3 all squared. So this will cancel, this will remain 6. What I have here will be, so let me just punch that, or let me simplify. I can say 2 here 3, 2 here 11. So I could say 1 over 3 times 11 over 7 times 9 root 3 all squared. That will give you 243. You could say 8 here 1, 8 here 81. So that will be 81 times 11 divided by 7, and that gives me 127.285 centimeter squared. So we have the area of the triangle and the area of the sector. So we can find the area of the shaded region to just be 81. So instead of saying 81 root 3, let me now get the value. So 81 root 3 is 140, and I'm just putting, so there is 140.296 centimeter squared. So that will be 140.296 minus 127.285. So 127.285, that gave me 13 points, basically 01. Let me see, did they tell us to do it to any decimal place? So to 2 decimal place, so to 01 centimeter squared to 2 decimal places. So this is how we actually solve this particular question. The trick here is knowing that this length here is not going to be 18, but you can find the length using this guy here, because from here to here is the same thing as the radius. And you know, you can use the Pythagoras theorem to be able to find what that radius is. So you can see that Pythagoras theorem is very, very integral. So many questions now, all using Pythagoras theorem. Let's see if answer is correct. Great. 13.01 centimeters squared to 2 decimal places. Question 6 now says that the area of a semicircle is 32 pi centimeters square. Find in terms of pi the circumference of the semicircle. This is from June 2023. Let's solve it together. So to solve this, let's say we have a full circle. This is our circle. The area of a full circle is what? That is pi r squared. So the area of a semicircle, that's like dividing it by 2, would be, let me just say, area of semicircle would be half of it will be pi r squared divided by 2. So if that is the case, we have our area of semicircle to be 32 pi, so that will be equal to 32 pi. And if you cancel here, I mean, you do something, you say your r squared is equal to 2 times 32. Your r squared is equal to 64. And then if you take the square roots of both sides, your r will be equal to 8 centimeter. I know that this cancel might confuse you, but just do it in a way that you can understand, right? In our semicircle, for a full circle, the circumference of a circle is what? 2 pi r, right? You say, oh, if you go around, it's, you say 2 pi r. But now we're taking half of it, right? This is the half. Remember, we cannot just take this part here and say this is it. No, we have to close it at the top. Do you get? So when we close it, so this part here, for this part here, the circumference of this would be half of this. So for the semicircle, that will be pi r. So this will be pi r. And of course, the thing that we used to cover it, remember, this is like radius. This is also radius. You can say plus d, or you can say plus 2r. Do you get? So that's curve plus the covering at the top. So now we know that, let's now substitute. So our circumference of the semicircle will be pi r, that will be equal to 8 pi plus 2r, that will be 2 times 8, which is 16. So our circumference of the circle is 8 pi plus 16. Let's see if we're correct. Great. Question 7 says that in the diagram, the radius of a sector of a circle O, and the center is O, is 7 centimeters. From here to here, 7 centimeters. From here to here, 7 centimeters. And MON, this is MON, this guy here, 60 degrees. Find, correct to 1 decimal place, the area of shaded portion. Take pi to be 20/7. This is also taken from June 2023. See the number of questions that are coming from just 1 year. So to solve this question, if you look at it, if I draw a line around it, you can see that what we have here is basically a sector. It's a sector. So I have to find the area of the sector. So inside that sector, we have a triangle. You can see the triangle here. So if I take out the area of the triangle, that will give me the area of the remaining parts. Great. And we're told that the theta is 60 degrees. So let's find the area of sector. Area of sector is theta over 360 times pi r squared. And that will be 60 over 360 times pi times, for the entire sector, the radius is 7. So that's 7 squared. And this is 6. So this would be 1 over 6 times 22/7 times 7 squared. So this will give you 25.6. How many decimal places we should use? 1 decimal place. So this is 67 centimeters squared. So we found the area of the sector. Next thing to do is to find the area of the triangle. So from here to here is 7, right? We have the angle here, 60 degrees. We can find the length of another side. Remember, this place here is not the entire 7. It's from here to here, that's the entire 7. But we know that this place will be 7, and we can find maybe this guy here and do half AB sine theta, because the theta is between this guy and this guy. Remember, your theta must be between 2 of those sides. It cannot be something here and you're picking this guy and this guy. No, it must be between them. So knowing that, if I draw out my triangle, this angle here is 60 degrees, this is at 90 degrees, this is 7 and 7 centimeters, and this is x. So I can find my x. So I could see these adjacent and hypotenuse. So that is cos. So cos 60 degrees is equal to x over 7, and my x will now be 7 cos 60 degrees. So 7 cos 60 degrees give me what? 3.5 centimeter. Right, so I have this guy, I can find the area. So the area of the triangle will just be half AB sine theta, theta being the angle between those two sides. That will be half times 7 times 3.5 times sine 60 degrees. So that will be 7 times 3.5 times sine 60 degrees, then divided by 2. That will give me 10.6 centimeters squared. So I know the area of the sector and the area of the triangle now. I can find the area of the remaining parts by saying 25.67 minus 10.6. So if you subtract this, we're going to have 15.07 centimeters squared. So to one decimal place, that will be 15.10 centimeters squared, or approximately 15.10 centimeters squared to one decimal place. Right, it should never be 10, let's just say 1. So 15.1 centimeters squared to one decimal place. So the thing to note here is that when you're given this kind of questions, don't go and say, oh, the length of the base of the triangle is 7. No, it's just a portion of that 7. I need to find that portion. Then, I mean, you have the angle between those two sides. You can find the area and subtract. Let's see if our answer is correct. Great. Question 8 says that the length of a rectangle is 4 centimeters more than the width. If the perimeter is 40 centimeters, find the area. Let's take from June 2023 also to show you how important this past question is. Let's solve it together. So we're told that the length is 4 more, so that will be width plus 4 centimeters. Perimeter is 40 centimeters, and find the area. Great. We know that the area is the length times the width. We also know that the perimeter is what? 2 open brackets L plus W. So if so our 2L plus 2W is equal to 40. We're told that the L is W plus 4. So that will be 2 open brackets W plus 4 plus 2W is equal to 40. That will be 2W plus 8 plus 2W is equal to 40. Then if I carry this up, this would be 2W plus 2W will be 4W plus 8 is equal to 40. 4W will be equal to 40 minus 8. 4W will be equal to 32. If I divide both sides by 4, W is equal to 8 centimeters. So if our W is equal to 8 centimeters, then our L will be equal to what? W plus 4, which will be equal to 12 centimeters. So our area now would be 12 times 8, which would be 96 centimeters squared. Let's see if we got it right. Great. Question now says that a rectangle has width 3/4 centimeters and the area is 3/8 centimeters squared. Find the length. I'm sure there's something you can do in a jiffy, but let's solve it together. So the width is 3/4 centimeters. The area is 3/8 centimeters squared, which is I'm saying 8 times 3, 24, plus 3, 27/8 centimeters square. So we're also find the L, which is question mark. But we know that the A is equal to L times W. So the L will just be A over W. So substitute that our A is 27/8 divided by W, which is 3/4. So that will be 27/8 times 4/3. 3 here 1, 3 here 9, 4 here 1, 4 here 2. That will be 9/2, which is something saying 4.5 centimeters. So that is our answer to this question. That will be option B. Great. Question 10 answers that a trapezium of parallel sides 10 centimeters and 21 centimeters and height 8 centimeters is inscribed in a circle of radius 7 centimeters. Calculate the area of the region not covered by the trapezium. Take pi to 20/7. Let's take it from June 2021. I want you to also pause the video like you have been doing and solve this, but let's solve it together. So if this was our circle, we have a trapezium inside. So inscribed, this will be the first parallel base and this will be the second parallel base. Let's see this guy here, and this will be like here the legs, and this will be the second leg. Great. Then of course for a trapezium, these guys are parallel, the bases are parallel. This side there is 10 centimeter, this side there is 21 centimeter. Of course, this is not drawn to scale, I have to say that. And the height of this guy here is 8 centimeter. Great. Once again, this is not drawn to scale. So it says that we should find the area of this portion, of this other portion that is not covered by the trapezium. Right. So we have the circle. So the area of the circle minus the area of the trapezium. This trapezium will give us the area of, let's say, the shaded region. Right. So we have the area of the full circle minus that guy that the trapezium covers. That will give us the area of the shaded portion. So we're told that the radius of the circle is 7 centimeter. So if we want to find the area of the circle, that will be pi r squared. That will be 22 over 7 times 7 squared. One of the 7s will cancel. So 22 times 7, that will be 41154 centimeter squared. So we have the area of the circle. So the area of the trapezium is half a plus b multiplying the height, right? Perpendicular height. That will be half times the a is 10, so that will be 10 plus 21 times 8. We already told that. So that will be half times 31 times 8. This will cancel, this will cancel, this will be 4. And that will give me 4124 centimeter squared. So we already have this guy, we have this guy. So the area of shaded portion, right, will just be 154 minus 124, and that will give you 30 centimeter squared. Basically, that's how to solve this question. Let's see if we're correct. That will be option C. Question 11 says that the height of an equilateral triangle is 10√3 centimeter. Calculate its perimeter. This is from June 2021. I believe that you've paused the video and you've tried that out. So we have this. One thing we know about equilateral triangles is that all sides are equal. So this is x, x, x. The height is 10√3, and the height will divide this guy. So this will be x over 2. This will be x over 2 because it's an equilateral triangle. This is 60 degrees. This is 60 degrees. This guy is also 60 degrees, but it's divided into, so that's this like 30 degrees and 30 degrees. Because it's an equilateral triangle, this line is going to divide this guy into 2 equal halves. If it's another triangle, it might not. So let's take one half. If I take this half, this guy here is 60 degrees. This guy is x, this guy is x over 2, and this guy here is 10√3. This is 90 degrees. So from Pythagoras, our hypotenuse squared is equal to opposite squared plus adjacent squared. The hypotenuse is x, that will be x squared, plus opposite is 10√3 all squared, plus adjacent is x over 2 all squared. So that will be x squared. 10√3 is 300 plus x squared over 4. So if I take this guy to the other side, that will be x squared minus x squared over 4 is equal to 300, and that will be 3x squared over 4 is equal to 300. Right. You resolve this in the way that you know. I'll just do this in the way I know. So x squared will just be, if I cross multiply, that will be 100 times 4, which will be 400. So my x will be square root of 400, which is 20 centimeters. So one side is 20 centimeters. To find the perimeter, therefore we could just say that the perimeter is equal to 3x, right? This side plus this side plus this side, and that will be equal to 3 times 20 centimeter, which is 60 centimeter. Basically, this is our answer to this question. Let's see if we're correct. That will be option B. Question 12 says that diagonals of a rhombus are 12 centimeter and 5 centimeter. Calculate its perimeter. This is from June 2021. So we have our rhombus here, and we have the diagonals. Let's say this is the first diagonal, and this one is the second diagonal. No said about rhombus is that the diagonals bisect each other. This guy is one for the 12. This will be 6 centimeter. This will be 6 centimeter, and this guy is one for the 5. This will be 2.5 centimeter and 2.5 centimeter. And also we said they bisect each other at 90 degrees. So if I take one side, if all the lengths are x, 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 remember in the rhombus, all the sides are equal. We checked that before. So these 90 degrees, these are x. This guy here is 2.5 centimeter. This guy here is 6 centimeter. So I could say from Pythagoras, our hypotenuse squared is equal to opposite squared plus adjacent squared, and that would be x squared is equal to 2.5 squared plus 6 squared. 2.5 squared is 6.25, 6 squared is 36, so if I add both of them, that would be 42.25 as my x squared. So my x would be square root of 42.25, so that would be square root of 42.25. My x is equal to 6.5 centimeters. So I know the side of 1. So the perimeter will just be x plus x plus x plus, which is 4x. So that will be 4 times 6.5. And that will be 26 centimeters. So that's how we solve this question. Let's see if the answer is correct. That will be option A. Question 13 says that Johnson and Jogator Limited owned a business office with floor measuring 15 meter by 8 meter, which was to be carpeted. The cost of the carpeting was 890 cedis per square meter. Take note of that, 890 cedis per square meter, that means per area. If a total of 216,120 cedis was spent on painting and carpeting, how much was the cost of painting? This is taken from June 2021. As always, pause the video and try it out. Don't look at the solution before you try it out. So the office measured 15 by 8, so the area of the floor is 15 times 8, and that will give you 120 meters squared. They said the cost of carpeting was 890 cedis per square meter, so 890 cedis for 1 meter square, right? And 120 meters square. So how much was used for 120 meters square? So if I cross multiply, x times 1 is x, so that means my x would be equal to 890 times 120. That means that the cost of the carpeting was cedis 106 800. So 106,800 Ghanaian cedis. That was what was spent on carpeting. But it said a total of 261.20 was spent on painting and carpeting. We want to find out how much was spent on painting. So total cost is cost of painting plus cost of carpeting. We know that this x, which is our cost of carpeting, is 106,800. So that would be cost of painting plus cost of carpeting, and the total was 216,120. So cost of painting will be 216,120 minus 106,800. So the cost of painting is 109,320 cedis. Simple and short. Let's see if the answer is correct. Great. Question 14 says that in a triangle PQR, if the angle PQR, that is the angle at Q, is 90 degrees, right? We're not told that the area is 216 centimeters squared. If the ratio of the length of PQ to QR is 3/4, find the length of PR. Let's take from June 2021. I want you to pause the video and break this down yourself. So we have a triangle. We're told that the angle Q is 90 degrees. So if this was P, these are Q, these are R. This place is 90 degrees. And the area is 216 centimeters. We're told that the ratio of PQ to QR is 3/4, right? You know, when I told you that when you see something like this, these are not, I mean, it could have been 9/12. It seems 4. It could have been 6/8, same as 3/4. So we don't know the exact true length. So what I always do is that for my PQ, I'll just say 3x, right? X could be anything, and then for my QR, I will say the QR is 4x. X could be anything, so it could be any multiple. We were told to find the length of PR. We're told that the area is 216 centimeters squared, and the area of a triangle is half base times height, right? 216. So half, what is the base? The base is 4x. What is the height? The height is 3x is equal to 216. 2 comes 1, this will be 2x. So 2x multiplying this, not plus. So 2x times 3x, that will give me 6x squared is equal to 216. If I divide both sides by 6, my x squared is equal to 36, and then my x is equal to 6 centimeters. Great. So that means that this guy is actually 3 times 6, which is 18, and 4 times 6, which is 24 centimeters. So this is actually the length of these guys. So now the length, we can find the length of PR. So from Pythagoras, why is it Pythagoras? Because it's a right angle triangle. We say the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Hypotenuse squared is the PR which we're looking for. So PR all squared is equal to opposite is this guy, which is 18. So 18 squared plus 24 squared. So 18 squared is 324 and 24 squared is 576. So if I add this to 324, this gave me 900. So my PR will just be taking the square root of both sides, that will be square root of 900. So my PR is 30 centimeters. So the length of PR is 30 centimeters. Let's see if we're correct. Great. Question 15 says that in the diagram PQRS, there is a trapezium with QR. So these are QR parallel to PS, line PS, and UT or U and T are points on PS. So this point to this point C on PS, such that PU is 5, QU is 12, and the angle at U between P and Q is the same as the angle at C between S and R, and they're both 90 degrees. Great. So it says that if the area of PQR is 20 centimeters squared, so this P, this Q, and this R, so if that area is 20 centimeters squared, calculate and correct the nearest whole number, the perimeter, and then the area of the trapezium. This is taken from June 2021. You can pause the video and as well try this. So to solve this, if QU is perpendicular and this line is parallel, this line is parallel, then that means that this place is 90 degrees, place is also 90 degrees, right? And if this is also parallel to this line and this QU is said to be perpendicular, this one will also be perpendicular, right? We just know that. And this line here is perpendicular to this line, this place here will also be perpendicular. And since these two lines are parallel, this place will also be perpendicular, right? We know that. If this place is 12 centimeter, this line is also 12 centimeter. So I can find this X and I can find this Y, right? Because I'm trying to find the perimeter of the whole thing. So if I take out that small triangle, let me take out the small triangle. This angle here is 50 degrees. These are X, these are Y, these are 12. So from SOHCAHTOA, we have the opposites and hypotenuse. So that's sine. So sine 50 degrees is equal to 12 over X. So if I cross multiply, my X would be 12 over sine 50 degrees. So if I point that to my calculator, that's 12 divided by sine 50 degrees. That gives my X to be 15.66 centimeters. So this guy here is 15.66 centimeter. Likewise, we can find our Y by saying adjacent and opposite. So adjacent and opposite is tan. So tan 50 degrees is equal to opposite is 12, adjacent is Y. So our Y will be equal to 12 over tan 50 degrees. So our Y will be equal to, let's point that to the calculator. So that will be tan 50 degrees, and that gave me 10.07. So Y is 10.07 centimeters. So this guy is 10.07 centimeter. We have this length, we have this length, we have this length, we have this length, we don't have this length. Let's find this length. So we could say, let me just build this out and say this from this triangle. Don't mind my triangle. We know this place here is at right angle. This 12 centimeter, this 5 centimeter, because the right angle triangle can use Pythagoras. So we could say from Pythagoras, the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Hypotenuse is what we're looking for. Let's call it Z. So Z squared is equal to opposite squared is 12, so that's 12 squared plus 5 squared, and that's equal to 144 plus 25, which is equal to 169. So if I take square roots of both sides, right, our Z will just be equal to 13 centimeters. So this guy here is 13 centimeters. So we have this guy, this guy, this guy, this guy. So it means this length here, this length QR and the length UT, which are the same. Look at the triangle. They gave us this triangle. What did they say? They said the area of the triangle PQR is 20 centimeters. So let me bring out that triangle. So we have this, and we have this. So we're trying to find this place here. Let's call this W. You know this place is 13 centimeter. This is the base. So if I flipped the triangle the other way around, like if I raise this part up, you see that this is the base, right? And we're given the perpendicular height. So although you might not know, but this, if you look at this plane, although this place is a bit extended, but if you look at the plane is going like this, right? And we're given this perpendicular distance. We're given this perpendicular distance. This is the perpendicular distance here. You can see this is the vertex here, and this is the plane of that vertex. The perpendicular distance from this place up onto this place here, that plane of the vertex, is 12 centimeter. So given that information, we can be able to solve this. So the area of this triangle is half base times height, and we're told that it's 20. So 20 is equal to half times the base here is W. The perpendicular height is 12. Remember, it's the perpendicular height we're using. We're not using this one. Of course, you could have done a solution that you can find this angle, then you have this total angle and say half AB sine theta, and you find the answer of this guy, right? That could be a little bit complex, but for simplicity's sake, you have the base and you have the perpendicular distance. So 2 year 1, 2 year 6, 20 is equal to 6W. So if I divide both sides by 6, so 20 divided by 6, our W is equal to 3.33 centimeters. So this place here is 3.33 centimeter, and this place here is 3.33 centimeter, because they are both parallel to each other. And then you can see this is a perpendicular line, this is a perpendicular line, so that it has given us the boundary. You get perpendicular line, and they are both parallel to each other. So I mean, they have the same length. So we can find the perimeter now. So A perimeter is equal to, I just need to add up all these places here. So I'll just punch it. I will have written out all the places I'm adding, but I don't have the space. I think I have. So let's just write it. So that will be 13 plus, let me go from here to here, 3.33 plus 15.66 plus 10.07 plus 3.33 plus 5 centimeters. So let's count, let's solve that. 13 plus 3.33 plus 15.66 plus 10.07 plus 3.33 plus 5. That gave me 50.39 centimeter, but it said to the nearest whole number, so that is approximately 50 centimeter. So to the nearest whole number. Great. So B says that we should find the area, right? And how do we find the area of a trapezium? We say half the addition of the two bases times the height. So this base here, the first base is 3.33, so that will be half 3.33 plus the other guy, this other one down here. So that's 5 plus 3.33 plus 10.07. So this is 18.4 plus 18.4, and then the height is 12. So plus 3.33 divided by 2 multiplying 12, and that gave me 130.38 centimeters squared. But it said to the nearest whole number, so that is approximately 130 centimeters squared to the nearest whole number. So that's how we solve this particular question. Let's see if our answer is correct. Great. Question 16 now says that a rectangular board has a length of 15 centimeter and width x centimeter. If the sides are doubled, find the new area. This is from June 2019. So the length of the board is 15 centimeter. The width of the board is x centimeter. If the sides are doubled, so it now became 15 times 2, which is 30 centimeter, and this one now became 2x centimeter because they are doubled, right? That is multiplying by 2. So where's the new area? We know our area is length times width, so our new length is 30 and our new width is 2x, so that will give us 60x centimeter squared, and that will be option A. Great. Question 7 says that in the diagram PQRS, so let's look at P, this P, this Q, this R, this S, and the angle at Q between P and R, angle at Q between P and R is equal to the angle at R between P and S. So this place here too is a right angle, right, because they're all equal to 90 degrees. And PQ, so this PQ is equal to 3 centimeter, QR is equal to 4 centimeter, PS is equal to 13 centimeter, and we're told to find the area of the quadrilateral. So we have established that this guy here is a right angle triangle, right, because of the angle at Q between P and R is 90 degrees. So we can split into two triangles. So this triangle 1 and triangle 2. The moment we have the area of this one, the area of this one, we'll add them together to give us the area of the quadrilateral. So for the first triangle, let me draw it out. So in the exam, I want to draw out the one you're talking about so the lecturer knows what is marking. This is 3 centimeter, this 4 centimeter. So we can find the area of this. So the area of this is basically just half base times height, which is half times 4 times 3. 2 here 1, 2 here 2. So that's 6 centimeter squared. Now for the second one, we have this guy, we have this guy, we have this guy. So we have the hypotenuse. We can find the height, perpendicular height from this guy here, right? So for the second guy, let me just bring it down. We have something like this. These are 90 degrees. This place here is 13 centimeter. This place here is X. This place here is Y. So we can find X. So if these, you can see from figure 1, Abby, we can see the hypotenuse squared is equal to the opposite squared. Okay, so let me just put it under the figure 1 so that it doesn't confuse anything. So we will say from Pythagoras, we know that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. What is the hypotenuse? We don't know it, but we know the opposite to be 3 squared and then the adjacent to be 4, so that will be 4 squared. So that's 9 plus 16, and that is equal to 25. So the hypotenuse would be equal to square root of 25, which is 5 centimeter. Great. So that means that this guy here, which is like the X, is 5 centimeter. So I don't need to put X again. I can just put my 5 centimeter. So just take this out. So this is 5 centimeter. So I can find my Y also. So from Pythagoras, the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So we know this to be 13, so that will be 13 squared. The opposite to be 5, that will be 5 squared. The adjacent to be unknown. Right, we said that is Y, so let me just put that as Y. So that's Y squared. So this 169, I bring this one over, this is minus 25 is equal to Y squared, and this will be 144 is equal to Y squared. So if I take the square roots of both sides, my Y would just be equal to 12 centimeters. So that means that this guy here is 12 centimeters. So I can find the area. So this is A1, and I can find A2, which will be half base times height, and that will be half times 12 times 5. 2 here 1, 2 here 6. So 6 times 5 is 30, so 30 centimeters squared. So the total area would just be A1 plus A2, and that will give me 6 plus 30, which is equal to 36 centimeter squared. And that answers the question that we have been asked. Great. Question 18 now says that in the diagram POS, so this POS and ROT are straight lines. OPQR is a parallelogram. You can see this side is parallel to this side and this parallel to this side. Remember, in parallelograms, opposite sides are parallel to each other. OS is equal to OT. Yeah, you can see the mark here, the mark here. So what type of triangle is this? What type of triangle is this? It's an isosceles triangle. Great. So that means that if this angle is 50 degrees, this angle to also be 50 degrees. And we can find what this angle is. Great. So now says that you should calculate the value of OPQ. Find the value of this guy here, the angle here. So like I said, if this guy is 50 degrees, this guy is 50 degrees, since it's a isosceles triangle. And angle in the triangle is 180 degrees. So we could say angle SOT is equal to 180 minus 50 minus 50, and that will give us 80 degrees. So that means this guy here is 80 degrees. I know we've not reached this, but if we have an X like this, if we have an X, I think that will be maybe the next 2 topics we're talking about angle in the line and all those things, right? But if we have an X like this, the angle here is same as the angle here. So that means this guy is 80 degrees. This guy here too will also be 80 degrees. Are we good? Great. So what do we say about the lines of a parallelogram? So remember we said opposite sides are equal and parallel. Opposite angles are equal. So it says consecutive angles are supplementary, they add up to 180 degrees. I'm talking about supplementary angles I've said diagonals bisect each other but are not necessarily equal. Given that said consecutive angles are supplementary, so if this guy is 80 degrees, this consecutive angle is the angle next to it. So this guy here would just be, if I come here, so I'll say the angle at OPQ would just be equal to 180 minus 80, right? And that will be 100 degrees, because supplementary means that they add up to 180 degrees. So this guy plus this guy must be 180 degrees. So if this guy is 80 degrees, this other guy is 180 minus 80, and that will give you 100 degrees. So if you were actually solving this as a theory question, you'll be given all those laws. So you say, oh yeah, you say angle in a triangle, so just in the triangle is 180 degrees. Or you can say sum of angles in a triangle, and yeah, you could do, your reason will be, you say consecutive angles are supplementary. You could just say open bracket adds up to 180 degrees, right? You know, say therefore angle PQ. So you get, you must give reasons behind everything that you're doing. You just put and expect that the teacher will understand what you're saying. When you're solving questions, solve it like as if you're explaining to a child, so that the teacher can give you the full mark and you can know that you actually understand what you're doing. So that is option A. Great. Question 19 says that in the diagram, WXYZ is a rectangle with dimensions 8 cm by 6 cm. PQRS are midpoints of the sides of the rectangle are shown. Using this information, what type of quadrilateral is the shaded region? Is it trapezium? Is it prism? Is it rectangle? Is it rhombus? If you look at all these things, you will say, okay, it looks like a rhombus, right? But you must prove it. So if this guy here is, the length is always greater than the width. So if this guy here is 8 cm, this guy will be 6 cm. And because they said that these are the midpoints, so this guy is 4 cm, this guy is 4 cm, this guy is 3 cm, this guy is 3 cm. So likewise, this guy will be 4 cm, this guy will be 4 cm, this guy will be 3 cm, this guy will be 3 cm. So you can see this 4 3, this 4 3, this 4 3, this 4 3. So you can assume that this guy here will always be the same length, always be the same length, always be the same length, always be the same length. And that is the characteristic of rhombus, that the lengths of these guys are the same, right? And you can see it's always shaped like this, right? If you think that we're lying that these guys are all the same, we could do from Pythagoras, because this is a rectangle, so this guy is 90 degrees. So if I take one of the, let me just take this one here. So if I do like this, right, this is 3 cm, this is 4 cm. So we could just say from Pythagoras, right? The hypotenuse squared is equal to the opposite squared plus the adjacent squared, and that would be 3 squared plus 4 squared. That would be 9 plus 16, and that would be equal to 25. So the hypotenuse is 5 centimeters. If you take the square root of both sides, this guy is 5, this 3 4 5, 3 4 5 5. So you can see this is a rhombus. And because they did not put square, because that square could also be confusing, right? So that is option D. Question 29 says that same question, but you should calculate the area of the part of the rectangle that is not shaded. So let's solve that. We've said that these guys here are 5 centimeter each, right? 5 centimeter each, and we said that this guy is 8 centimeter, this guy is 6 centimeter. So the area of the shaded region, we have a full rectangle, so that will be area of the rectangle minus the shaded region is just the rhombus. So if I take the area of the rhombus RH from the area of the rectangle, right, I would have my answer. So this is one way of finding the area of shaded region. Or you can say each of these guys is a triangle. We said this guy here is 4 centimeter, we said this guy is 3 centimeter. So we have the triangle, right? One triangle. So this is another way of solving this, which I think is the easier way, because for this one, you know, we would actually need the length of the diagonals, which we can actually find, but this guy here is actually shorter. So we have the triangle here, this triangle, this triangle, this triangle, this triangle. So if I find one of the areas of the triangle and I multiply by 4, it will give me the area that is not shaded, right? So this guy here is 3 centimeter, this guy is 4 centimeter. So the area is half base times height, which is half times 4 times 3. So this is 2 here 1, 2 here 2, 2 times 3 is 6, that's 6 centimeters squared. So that means that the area of one of these sides here is 6 centimeters squared, right? So the total area of the unshaded region, that will be, how many of them do we have? We have 4, so 4 times 6, and that will be 24 centimeter squared. Let's see if the answer is correct. That will be option B. Question 1 says that the diagonals of a rhombus WXYZ, they intersect at M. If MW is equal to 5 centimeter and MX is equal to 12 centimeter, calculate its perimeter. Take from June 2018. So if these are rhombus, then the diagonals, this is the first diagonal and this is the second diagonal. So the rhombus was W, X, Y, and Z. So the intersect at M, this is M. So MW is 5 centimeter and MX is 12 centimeter. And remember, a rhombus, they intersect at right angle. So this is a right angle here, there's a right angle somewhere here. So if I take out one of those triangles, right, so this guy here, this is 12 centimeter, this 5 centimeter, we can find the length as X. So we could just say from Pythagoras, the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So that would be X squared is equal to 5 squared plus 12 squared. So that will be 25 plus 144, and that is 169. And if I take the square roots of both sides, my X will be equal to 13 centimeter. So that means this guy is 13. So that means the perimeter will just be 4 times 13, right? Because 1, 2, 3, 4. That will give me 52 centimeter. So you know, there are some actual common sides for a distance. I mean, I think it's 3, 4, 5, 3, 4, 5. There's 5, 12, 13. So if two sides are 5 and 12, that last guy will be 13. And I think multiples of them. So I mean, if I say times, so that will be 6, 8, 10 times 3. That will be 9, 12, 15. So by the time you start seeing some of all those things, reading that the last side or the missing side is 5, the missing side is 4. If two guys are 5 and 12, now the missing side is 13. But if you don't know how to remember this, please just use your Pythagoras theorem. It's just going to take you maybe 1 minute extra. So let's see if our answer is correct. That is C. Question 2 now says that in the diagram, PT is parallel, so this PT is parallel to SU, QS is parallel to TR, SR is 6 centimeter, RE is 10 centimeter. If the area of triangle TRU is 45 centimeters squared, calculate the area of the trapezium QTUS. So QTUS. So this is the area of trapezium that we are. So this QTUS, this is the trapezium that we're finding the area. We're told that the area of the triangle CRU is 45 centimeters. So we know that the area of a triangle is half base times height. So that will be half times the base is 10 times the height is unknown, perpendicular height. That will give us the height of the trapezium. But this is 45. 2 year 1, 2 year 5. So 45 is equal to 5h. So our h is equal to 45 over 5. Our h is equal to 9 centimeters. So this is 9 centimeters. If this guy is 6 centimeters, this guy is also 6 centimeters, right? Because this guy is parallel to this guy. That puts parallel. So this line is the same thing as the length of this line. Now that we know that our area for trapezium is half a plus b h. That will be half. A is 6, b is 6 plus 10, which is 16. Our h is 9, so that will be half times 22 times 9. 2 year 1, 2 year 11. 11 times 9, so the area of trapezium is 99 centimeter squared. Great. Question 23 says that a circular pond of radius 4 meter has a part of width 2.5 meter around it. Find, correct to 2 decimal places, the area of the part, taking pi to be 22/7. This is from June 2017. So imagine this was our first circle, which is circle of the pond, and then we have another circle, a bigger circle. So this is the circular pond, right? The radius of this guy, so from this guy here, is 4 meters. Then that's a part of 2.5 meters round it. Remember, although my circle is not showing that they have the same starting point, but if this guy here, if the width of this guy is 2.5, this guy is 2.5 meters, and that means that from this center to this place here is 6.5 meters. So 6.5 meters, right? That's how we solve it. So it's now telling us that we should find the find correct to 2 decimal places the area of the parts. Correct. So the area of the parts, look at, if I remove the area of this pond from the area of the big circle, do you agree that we have the area of the parts? Yes. So the area of the parts is equal to the area of the big circle minus the area of the pond or the small circle. So the area of the big circle is pi r squared, right? And that will be pi, or let me just 22/7. 22/7 times the r is 6.5, so that will be 6.5 all squared. Let's punch that. 22 divided by 7 times 6.5 all squared. That will give you 132.785 or 786 if I'm going to 3 decimal places. And then the area of the pond would also be pi r squared, which would be 22/7 times 4 squared. So 22/7 times 4 squared, that will be 50.286 meter squared. So this is also meant to be meter squared. So if you substitute for this guy here, the area of parts would just be 132.786 minus 50.286, and that would be 82.5, but it's set to 2 decimal places, so that would be 2.50 meter squared. So that is the answer for this particular question. That will be option D. Question 24 says that the diagonal of a square is 60 centimeters. Calculate its perimeter. This is from June 2017. So these are square. Let's put the diagonals. So this is the first diagonal, and then the second diagonal. Great. So the diagonal, this is 60 centimeter, and this 60 centimeters. So this x is also x, because it's a square. If this side is this side is x, and of course each of the sides are 90 degrees, 90 degrees, 90 degrees, 90 degrees. So I'll just take one part. So let's take out one part of the triangle. So this 90 degrees, right? This x, the diagonal here is 60 centimeter. So from Pythagoras again, We know that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So that will be 60 squared is equal to x squared plus x squared. So that will be 3600 is equal to 2x squared. If I divide both sides by 2, our x squared is equal to 1800. So if I take the square root of 1800, that will give me my x to be 30 root 2. So now that we know that the side of one part is, I'm sure you know how we got this 30 root. That is square root of 900 times 2, and square root of 900 is 30, so 30 root 2. We know that this part here is 30 root 2, so we can find the perimeter. That is just saying 1 2 3 4. That is saying perimeter is equal to 4x, which will be equal to 30 root 2 times 4, which is 120 root 2 centimeter. So this is our answer for this question. Great. Option D. Question 25 says that which of the following is true about parallelograms? This is from June 2017, and it's talking about the opposite angles are supplementary. Supplementary means that they add up to 180. Opposite angles are complementary, mean that they add up to 90 degrees. Opposite angles are equal. Opposite angles are reflex angles. That means that they're between 180 to 360 degrees. Let's see which of this is true. Let's say we have a parallelogram. In a parallelogram, this side is always equal to this other side. So let me just duplicate this line. We always have something like this, and then we'll join this line here and say, okay, this side is, and this other side so will be parallel. So if this is a parallelogram, this side here would be parallel to this side, and this side will be parallel to this side. So what can we say about opposite angles? So these are opposite angles. The first one is wrong. Opposite angles are not supplementary. It is adjacent angles, like this angle and this angle, that are supplementary, or this one and this one that are supplementary. We talked about that before. But if you have this angle and this angle is angle x, right? Since this side is parallel to this side, that means that this angle here too will be x, right? Look at this side is parallel to this side, and like it's still the same horizontal line. So if this guy is x, this guy is x. We've not reached there yet, but when we're talking about angles in the line, you see that when there is an angle z, right, this angle here is equal to this angle here. Remember, I also said that when there's an angle x, this angle here, let's say this x degree, is also equal to this angle here. So this is another one I'm teaching you before then. So when you have a z, the inside of the z's, this side here is equal to this side. So you can see that we have a z here. So this side here will be equal to this side. So you can see that opposite angles are actually what? Equal. Opposite angles. So opposite angles are not the same as adjacent angles. Adjacent angles, these are opposite angles. Opposite angles are equal. That will be option C. So if you have forgotten all these things, once you know your angles in the line, which we're going to choose very soon, you say that you'll be able to solve questions like this. Maybe you might just be confused by the word supplementary, complementary, but once you know that supplementary is 180 degrees, complementary is 90 degrees, reflex angles that goes between 180 and 360 degrees, you're good to go. Question 6 is that the diagram MOPQ, so these are M, these are O, these are P, these are Q. MOPQ is a trapezium where QP, this QP is parallel to MO. You can see this 3 and this 3. MQ, so this MQ is parallel to NQ. NQ, this one arrow and this one arrow, so they're parallel to each other. NQ is parallel to OP, so this NQ, see these two arrows, so they're parallel to each other. And QP is 9 centimeter, and the height of triangle QNP is 6 centimeter. Calculate the area of the trapezium. Take from June 2016. So one thing we need to notice is that this guy is parallel to this guy. So that means that this distance here will also be this distance here. Since these two guys are parallel to each other, that means this is 9 centimeter. Also, too, this guy here is parallel to this guy. Can you see that? So whatever this distance is, this distance will also be it. So this is 9 centimeter too. Everything you need in all these questions are always given, so you just have to read between the lines. I was told that the height, this guy here, is 6 centimeters. That is the height of this triangle QNP, which would be the same thing as the height of the trapezium. So what do we know as the formula for the area of trapezium? We say the area of trapezium is half A plus B h. Our b here is 9 plus 9, which is 18 centimeter, right? So that will be, we can say a is equal to 9 centimeter, b is equal to 18 centimeter, h is equal to 6 centimeter. Please, in your WAEC, always ensure that you solve, like you don't just use calculator and just jump, just say half 9 plus 15 and just plug. Please break everything down. These are things that make people lose marks. So the area of the trapezium is half 9 plus 18 multiplying 6. Like this time, I'm not just plug all of this to my calculator, I will solve it. That is half times 27 times 6, 2 here 1, 2 here 3. So 27 times 3, that is 1, 2, that will be 81 centimeter square. Always ensure that you put your unit after everything. If you are putting the given, if you are putting your answer, if you don't put units, you've lost the mark of the answer. You might get the mark of the step, but you've lost the mark of the answer. Let's see if the answer is correct. That will be option C. Question 7 says that in the diagram PQST, so these are P, these are Q, these are S, these are T, is a parallelogram. PR is a straight line. TS is 8 centimeter. SM is 6 centimeter. And the area of triangle PSR. So this P, this S, this R. The area of this is 36 centimeter squared. Find the value of QR. Let's take it from June 2016. If this guy is 8 centimeter and this line is between two parallels, so this guy is also 8 centimeter. Right, we're told to find the length of this QR, so these are X, but we're told that the area of the triangle PSR is 36 centimeter. What do you know about area of triangle? Area of triangle is half base times height. So what is the base here? The base here is, say, PSR, so the base here is 8 plus X. That will be 8 plus X watts, so this is X centimeter. 8 plus X centimeter. Our height is 6 centimeter and our area is given to be 36. So let's substitute. That will be 36 is equal to half times 8 plus X multiplying 6, right? So 2 here 1, 2 here 3. So I have 36 is equal to 3 open bracket 8 plus X. I can divide both sides by 3. 3 will cancel 3, 3 will cancel 36, which give me 12. So 8 plus X is equal to 12, and then my X is equal to 12 minus 8, which is equal to 4 centimeter. So my X is 4 centimeter, which is the length QR. Is that what they said we should find? Yes. So we can say therefore length QR is equal to 4 centimeter. Great. So the question is that the diagram shows the cross section of a bridge with a semicircle or a semicircular hollow in the middle. If the perimeter of the cross section is 34 meters, calculate the length PQ and the area of the cross section. Take pi to 20/7 from June 2016. As always, pause the video and try it out yourself. So for this, imagine that this distance here is X. So that will be like the diameter of this our 4 semicircle. Then this distance here will be 4 plus X meters, right? So this is like X meters. So we know that the perimeter of the total shape, right, would be 4 plus, in brackets, 4 plus X plus 4 plus, this is not this X, so it's not the X, is the perimeter of the semicircle, then plus 2, right? But what do you know about perimeter of semicircle? You know, it's not even perimeter. You can call it perimeter, but the real word is circumference. So it's circumference. So circumference of semicircle. Circumference of semicircle here is, for a circle, circumference is pi d. So for a semicircle, that would be pi d over 2. Remember, there is no straight line here. Unlike that example that we did, that it was something like this, where you now said pi d over 2 then plus 2r because of this line here, but there's no line here, so we're good. So what is our pi d? Our pi is 22/7. Our d is X, then divide this by 2, which is the same as saying 22/7 times X times 1/2. So 2 here 1, 2 here 11. That will be 11x all over 7. Now that we know this, we can substitute this and say our PT, which is 34. So 34 will be equal to 4 plus 4 plus x, then plus 4 plus 11x all over 7, then plus 2. So 34 is equal to 4 plus 4, that would be 8 plus 4, that is 12 plus 2. Okay, so this is not complete. There's another 2. So if I'm complete, 4 plus x plus 4 plus 2. Okay, so there should be another 2 here. So that will be plus 2. So 4 plus 4 plus 4, that's 12, 14, 16. That will be 16 plus 11x all over 2. So that will be, then there's another plus x again, right? Plus x. God, please help me. So that will be 34 minus 16 is equal to 11x all over 7 plus x. So 34 minus 16 is 18. So 18 is equal to all over 7. 7 is 7. This will be 11x plus 7 in 1. That's 7 times, so that will be 7x. So that will be 18 is equal to 18x all over 7. So if you cross multiply, that will be 18 times 7 is equal to 18x, and by divide both sides by 18. This will cancel this, this will cancel this. My x is equal to 7 meters. You have to be very careful that you don't omit the CS, and you have to be careful with your addition. You can say I almost missed out a lot of things. The question is simple, but it's very tricky. So our length PQ, which is equal to 4 plus x, would now be 4 plus 7 meters, which will be 11 meters. Now that we know, we are told to find the area of the cross section. So for II, area of cross section. So look at, we have the rectangles. That will be area of rectangle minus, we have a semicircle that is cutting out of that place. So I'll just say minus the area of the semicircle. So for the area of the rectangle, that is length times width. Always ensure that you show your formulas. Our length is 11 times our width is 4. So that is 44 meter square. So for the area of the semicircle, our area of the circle is pi r square, but let me just use d because I have my x is like 7, right? So that will be pi d square over 4. That is the area of a circle, but we have a semicircle, so that will be divided by 2, and that will be pi d squared over 8. So our pi is 22 over 7. Our d is x, which is 7, so that will be 7 squared all over 8, right? So this is like saying 22 over 7 times 7 squared times 1 over 8. So this will cancel this. 2 here 4, 2 here 11. So I'm left with 11 times 7 divided by 4, which will give me 19.25. So this is 19.25 meters squared. So our area of cross section, right, this guy here, if I bring it down here, will just be 44 minus 19.25. So 44 minus 19.25, and that give me 24.75 meter square. So that's our answer for this question. Let's see if we're correct. Great. So 11 meters and 24.75 meters square. Question 29 now says that the diagram below shows a rectangle PQRS from which a square of side x centimeter has been cut. If the area of the shaded portion is 484 centimeters squared, find the value of x. This is from June 2015. This is similar to the previous question in another dimension, but it's the same thing. So if the area of shaded portion is 484 centimeters squared, we know that the area of the shaded portion will just be the area of the rectangle minus the area of the square. The area of rectangle is length times width, and that will be 20. No, this is the length. So 10 plus 10, that's 20, then plus x. So that will be 20 plus x multiplying the width, which is 20. Right, so we have this. So 20 plus x multiplying 20 meters squared. Right, so it's like saying, if I open that, will be 400 plus 20x brackets meters squared. That's the area of the rectangle. So the area of the square is x squared, right? Because x times x, or side square. So we have these two. Whether that the area of the shaded portion is 484, so that will be, this would be 484 is equal to 400 plus 20x minus x squared. If I take this one to the rest, that will be x squared plus 484. If I take this one to the rest, that will be minus 400. If I take this one to the rest, that will be minus 20x is equal to 0. I think I can adjust that. That will be x squared. So minus 20x meant to come next. Then plus 484 minus 400, that will give me plus 84 is equal to 0. So if I do these two guys together, that will be 84x squared. So I need to find two values that if I multiply, to give me 84 x squared, and if I add, give me minus 20x. So I have 84, 2 year 42, 2 year 21, 3 year, so this 2, 7, 7 year 1. So let me see, 2 times 2, 4, 4 times 3, 12, 12 and 7. No, that would not work. So 2 times 7, that will give me 14, and 2 times 3, that will give me 6. So I have 14 and 6. I think if I say minus 14x and then minus 6x, this will work. Minus as minus give me plus, minus 14 and minus 6, that will give me minus 20. So that we are good. So x squared minus 14x minus 6x plus 84 is equal to 0. So if I factor out x from this, that will be x over bracket x minus 14. And if I factor out minus 6 from this, that will be x minus 14 too is equal to 0. So what's the average minus 14? Minus 14, same thing, these two brackets, I'm good. So that will be x minus 6, x minus 14 is equal to 0. So that will be x minus 6 is equal to 0, or x minus 14 is equal to 0. So from this we could say that our x is equal to 6 or 14. So these are value for x. Great. So x is equal to 14 or x is equal to 6. Question 13 now says that in the diagram, M and N are the centers of two circles of equal radii 7 cm. So this guy has 7 cm, 7 cm. The circle intercepts at P and Q. So this P and this Q. If the angle at M and the angle at N is 60 degrees, so there are two similar triangles really. Calculate and correct to the nearest whole number the area of the shaded portion. This is from June 2014. So we have our circles here. So if you look at this guy here, there are two similar triangles, 7, 7, 6, 6. So if I divide this place by 2, the center by 2, and I'm seeing an area of a sector here. So if I divide this place by 2, not even area of a sector, area of a segment. So area of a segment here. So if you look at this, if I isolate one of these guys, you see it. So it's something like this. Although it might be hard to see, but something like this. Right, this place here, then there is a line here. This for one of them. Right, then the other one is the one that is coming like this. So it's coming like this, and then we're shading it. That one to has its own, like where it's coming from, but that's not what we are dealing with now. We're dealing with just one side, right? And this angle here is 60 degrees. So this is like area of a segment. Once I find one of them, I'll just multiply by 2, since it's the same thing, that does a mirror effect of each other. So for area of segment, we said that would be area of sector minus the area of the triangle. So let's take it one at a time. So for the area of sector, we said this is theta over 360 times pi r squared, and that would be 60 over 360 times 22 over 7 times the radius is 7, so that will be 7 squared. One of this becomes one of this. 60 here 1, 60 here 6, 2 here 3, 2 here 11, and that will give me 11 times 7 divided by 3. That gives me 77 over 3, or 25.67. Is this centimeter? Yes, centimeter squared. I have to be sure that it's centimeter before I go and put meter. And the area of our triangle. So if you come here to this place here, we have this 7 centimeters. This place also the radius to 7 centimeters, and we have an angle between the 2 points, or between the 2 sides. this 77, we have an angle between them 60 degrees, so that will be half AB sine theta, which will be half times 7 times 7 times sine 60 degrees. So that will be 7 times 7 times sine 60 degrees divided by 2. That will give me 21.22 centimeters squared. So the area of the shaded portion, so if I just let me just bring this further here and see, if I substitute, our area of shaded portion would just be 25.67 minus 21.22. So 25.67 minus 21.22, that will give me 4.45 centimeter squared. But that is just the shaded portion of one side, right? But we'll have two of it, so that will be the total area of shaded portion would be 2 times 4.45, right? And that will be 8.9 meter or centimeter squared. You must be very careful, don't use meter with a centimeter. So correct to the nearest whole number, so which is approximately 9 centimeters squared to the nearest whole number. Let's see if we're correct. Great. And the last question, is in a parallelogram PQRS. QR is produced to M such that the length of QR is the same thing as the length of RM. What fraction of the area of PQMS is the area of PRMS? 6 from June 21st. Let's solve this one together. So we have a parallelogram like this. This side is parallel to this side. This side is parallel to this side. This is PQRS. I said QR is produced to M, that means just extended to a point M, such that QR is the same thing as RM. So if this guy is X, this guy is also X, right? Because they are the same length. It now says what fraction of the area of PQMS. So they've already joined this guy. So they joined this guy basically. PQMS is the area PRMS. So there is a line here too. So they're saying PRMS. So this guy is X, this guy also be X. We know that already because there are two parallel lines. So these are diagram. If you don't draw the diagram and it's a theory question, if you missed it, that means that how did you even get the answer safe? Right. So we're looking for the area of PQMS. This PQMS, which is half A plus B H, right? Do we know what the H is? We don't know. So let's just say the H is H. So that would be half A is X, B is X plus X, which is 2X multiplying H, which would be half times 3X times H, right? And this would be equal to half 3X H. Now that we know that, the next thing to find is the area of PRMS. So this PRMS. So how do we do this? Just a base times height, right? Area of a parallelogram. You know, this one is area of a trapezoid. The first one is area of a trapezoid. The next one is area of parallelogram. So that would be base times height. We have the base to be X, and we have the height to be H. So it now says that what fraction of the, so this is a word problem. When I say word problem like this, I'll just say what fraction. Let me just say fraction of is multiplication of the area of, so that is area of PQMS is equal to the area of PRMS. This is the way I actually solve word problem. Of means multiplication, is means equal to. Once you know those two things, you can never be wrong. So I'm trying to find a fraction. So I'll just say fraction is what I'm looking for, times the area of PQMS. This is it here. which is half, or let me just say 3x h all over 2 is equal to area of PRMS, which is equal to xh. So the fraction is just xh. This will be divided by 3xh all over 2. So if I this, that will be xh times 2 all over 3xh. This will cancel this, and that will be equal to 2 over 3. So PRMS is 2/3 of PQMS. Alright, PRMS is 2/3. If you don't put that word problem like this, you might most likely miss it. You might get maybe 3 over 2 or something funny. Right, so just always say fraction of times area of this guy is equal to the area of this other guy, and you'll be fine. So our answer is 2 over 3, and that will be option C. Great. So with this, we've come to the end of the WAEC past question on area. I hope you found it useful. I hope you were solving along, and I hope that you're able to find value in what I've watched. And if you have found value, the best way to give me value is to watch the videos on YouTube, right, and bring as many people as you know to this channel. You don't want to be the only person passing when your friends are failing. Let's help each other. I'll see you guys in the next video. Bye for now.